Good morning, students. Today's topic is based on the connectives NAND and NOR under the concepts of fundamentals of logic. Let us discuss based on the NAND and NOR in the next one. So, for example, if you have any two propositions P and Q, if you have any two propositions P and Q, the De Morgan's law can be written in state of negation of P. All P and Q is nothing but negation of P or negation of Q, and negation of all P or Q is written as negation of P and negation of Q. So this law is, you're familiar with these two laws. Now whatever over here, it is read as not P and Q, and here it is read as not P or Q. So this can be also written as not and is there, right? So this can be written in terms of like this. So this is nothing but NAND operation, and this can be written as not and or can be written as P arrow mark downwards, since it is, you can just remember or, right? So down, this is and this is and itself, and this not, so it is NAND NOR. So that is equal to this expression. This not and this is replaced by this particular symbol, okay? So over here not and this and is nothing but it is read as NAND, P NAND Q, and this is P NOR Q. Okay, so let us see the definition. The compound proposition negation of whole P and Q is read as not P and Q, and is also denoted by this. The symbol is called the NAND connective. Okay, so this, whatever the symbol is there, right? So that is called the NAND connective, and this symbol is called the NOR connective. So the compound proposition negation of P and Q is read as not P and Q, and is also denoted by this particular symbol. The symbol is called NAND connective. Here NAND is combination of not and. So I told it is the combination of this as well as this particular expression. Okay, it is the combination of not and not as well as this particular and. The compound proposition negation of P or Q is read as not P or Q, and is also denoted by this particular logical connective. I mean, this is the NOR connective we are going to use. The symbol is called the NOR connective. Here NOR is a combination of not and or. So this is how we are going to see the definition of NAND and NOR. So remember, students, P, this is NAND, this is NAND. So it's easy to remember. If it is and, it is this, right? So NAND is this. If it is or, it is this symbol. So NOR is this particular symbol. So P NAND Q is equal to not, right? So meaning is nothing but this NAND is nothing but not and. So negation of all negation of P and Q. So you know De Morgan's formula is nothing but negation of P or negation of Q. Here this is nothing but for NOR, it is P Q and negation of P or Q, and that is equivalent to negation of P and negation of Q. So this I replaced with this not and or. So this is called as NOR connective. So this is regarding the NAND and NOR connective. The same thing is expressed over here. Thus we'll get this particular expression. So you should know that this is logical equivalent to this, and by De Morgan's law this is logical equivalent to this. This is logical equivalent to this. By De Morgan's law this is logical equivalent to. So the truth table will be what? What is the meaning of this particular this one? P Q is nothing but negation of P and Q. So you know that what is P and Q? When P and Q is true, only when both are 1. So what will be the not of P and Q? This is equivalent to not of P and Q. So when both are 1, it was 1 when it is P and Q. Now what will be the not? What is P and Q table? You remember you had P and you had Q. So 0 0 was 0, 0 1 was 0, 1 0 was 0, and 1 1 was also 0. So what is the negation of this entire statement? You know that this will be 1 1 1 sorry, this was 1, okay, 1 1 1, and this will be 0. 1 in P and Q, 1 1 gives always 1, rest all it was 0. So what will be the negation of this entire term? It will be 1 1 1, and this will be 0. So you can see here, over here, this is 1 1 1 and 0. What about P or Q? I'll write here, okay, P or Q for this. What about P or Q? Only when it was 0, it was 0, rest all it was 1. So what will be the not of P or Q? That is nothing but NOR operation, this symbol, right? This symbol. So what is this? Not negation of this particular term. What will be the negation? It will be 1, rest all the 3 cases it will be 0. So you can see over here, these all are the NOR operations. So this is the truth table, combined truth table of NAND and NOR. I hope it's clear with the NAND and NOR truth table. Now let us solve the problems. So example 1, they have stated that for any proposition P comma Q, prove the following. Okay, they have told that for any proposition P and Q, prove the following. So let us take a new page and let us solve over there. The question is, first question is, for any proposition PQ, they're told that this you have to prove logically equivalent to this. You can see here it is NAND, here it is NOR. Remember the symbol notation, students. Here it is NOR and here it is AND. So just remember, NOR is this way, NAND is this way, and NAND means not of P and Q, and this means not of P or Q. Then you know the formula. Meaning is this, meaning is this, meaning is this, and this meaning is this. So let us solve the first problem. First one they have told that negation of P Q is logically equivalent to negation of P, negation of, okay. So let us take left hand side. Let us take left hand side. I'll just take this particular section. Okay. Arrow. Second. Nothing but P. I took the left hand side. Let's just solve this. So over here, try to solve this. What is this meaning? First you put a formula for this. What is this meaning? It is NOR, it is NOR. So what this negation will be as it is. What is the meaning of this particular statement? It is nothing but negation of P, negation of P or Q. You know, formula was there. P NOR Q is nothing but not P or Q. Not hold the P or Q. Meaning is not P hold the P or Q. So what is this? What is this now? Apply the negation, you keep as it is. Apply the De Morgan's law. So it will be nothing but negation P and negation Q. Now what we want, here we have NOT and here we have AND. What we want actually, we want NAND. So directly we will get it as, this is not, this you take it as P and this you consider as Q. So here you have negation and here you have AND. So what it will be actually? So it is nothing but negation P as it is, this NOT and AND is written as NAND, this NOT and AND as written as NAND, and then you got negation Q. So this is how going to get left hand side is equal to right hand side. Let us solve the second problem. Second problem, they told that negation of P NAND Q is logically equivalent to negation of P NOR negation of Q. Similarly, how you solve this way, same way try to solve this way. So it is negation, what is this? P NAND Q. So meaning is what? Not all the P and Q. So the meaning formula for this is not P and Q. Correct? Not P and Q. Keep this not as it is. Apply De Morgan's law. What it will be? Not P or not Q. So what you want in the expression, not P is there, not Q is there, or and not is there. So I want only this particular connective, that is nothing but NOR connective. So you know that is over here and that is over here. So just write as it is, P NOR Q. So this is the required result I got. This is the required result I So this is the required result, what I'm supposed to. So this is regarding the example 1 and example 2. Just repeat. P nor Q is there, negation of P or Q. What I did first, I just applied De Morgan's law for this. I mean law, meaning of this. What is the meaning of this? Negation of P or Q. Then I applied De Morgan's law, negation P, and I got it as and negation Q. This and this will give you NAND operator. So I applied the NAND and I got the right hand side. Similarly over here I applied formula. This and this is NOR operator and I inserted over there. I got the NOR operator. So this is regarding the example 1. Now let us solve example 2. In this also they have told that for any proposition PQR, prove the following. So let us solve for one by one. For any proposition PQR, prove the following. That is left hand side is equal to right hand side, but it does not involve any NOR and NOT. We have to solve based on and or negation somewhere involved over there. So let us solve one by one. First one is P NAND Q NAND R. Okay, so that is logically equivalent to negation of P or Q and R. Negation of P or Q and R. So what will we do is we'll take left hand side, we'll solve the outer one, then we'll solve the inner one. So what is we'll take left hand side. This is NAND. Okay, this notation is NAND and this is NAND. Both are NAND. So we'll solve this way. So outer one, if I want to solve, what I need to do, P, let us take this as P and this as Q and this is NAND. So how can I solve? Put a bracket, then P, and within the bracket this will be Q part as it is. Okay, so what I did, this I replaced, this term I replaced with not and. So I got it as P and Q NAND R. Now again I'll solve this particular expression. Let this be as it is. This be as it is. So that will be P and what will be this section? What will be this section again? So it will be nothing but negation of whole Q and R. Okay. So just see right hand side what I want. You just check over here. What I want in the right hand side. I want in Q and R. So Q and R is there. So no need to apply De Morgan's law. Here this should be negation P. So just apply De Morgan's law. What it should be over here. Here it is whole negation. Apply De Morgan's law. What it will be for entire term. Negation P and negation. Sorry, here it will be when you apply De Morgan's law. Here not it will be not and it will be or. Negation of P and negation of whole P and Q. Let this term you take it as Q. What it will be? Negation of P and Q. So it is nothing but negation of P or negation of Q. Negation of Q. Since here already negation is there, both negation will get cancelled and it will be just Q and R. It will be just Q and R. So what is the required result? Negation of P or Q and R. So this is we got the required result. Let us solve the second one. Second one is P or Q. It is over here. NAND R. It is logically equivalent to P and Q or negation of R. So we'll try to solve this. So we'll first solve we'll write the question left hand side as it is. Q and R. We'll try to solve the outer one. So this is what again NAND itself. So we'll just try to solve the outer section. So the meaning of this statement is negation of a square bracket. Consider this as P. That is as it is you write. Okay, and this will be replaced by and this is R. Now let that negation be as it is. What is this again? It is nothing but not of P and Q. And this and as it is. Okay, now apply De Morgan's law. When you apply De Morgan's law, this and this will get cancelled. Why? Negation is already there, so it will be P and Q and this will be replaced by De Morgan's law. Whole De Morgan's law notation will be and will be or, and here we will get a negation. Meaning is nothing but what is the formula of De Morgan's law of this? P and Q. De Morgan's law, you know the meaning of this will be nothing but negation. Negation of P negation of P or negation of Q. Negation of P or negation of Q. So here it will be negation of P. Since already negation is there, this negation and this negation get cancelled, and this or I wrote as it is. Instead of negation of Q, instead of Q I have R. So it will be nothing but negation of R. So this is the required result I'm supposed to get. So this is regarding the example 2. Next, let us solve example within the example 2 third section, third problem. So the third one is P nor Q nor R and logical equivalent to negation of P and Q or R. P and Q and R, negation of P and Q or R. So let us take left hand side. Similar way, let us solve the outer one. Okay. So I'll solve the left hand side over here. So it is, what is the meaning? Negation whole P or this is as it is. So I just solve this particular notation, or I put here, not I put entire for the whole section. So let us this negation be as it is. I wrote P over here, or over here. Again for this I will try to solve. It will be nothing but negation out Q or R. Then apply De Morgan's law. It will be negation of P and it will be and this both negation gets cancelled. Then it will be Q or R. So this is the required result in the third one. Fourth one is P Q nor R is logically equivalent to P or Q and negation of R. P or Q and negation of R. So over here let us solve outer this section, then we'll go to the inner section. So it will be nothing but I'll replace this with not and or. Okay, so it will be not over here, entire section. Then you have P Q or R. This is the left hand side. Now I'll solve the inner one. So it will be not P or Q. This I solved. So P, this you know, it is not P or Q and or as it is. Now apply De Morgan's law. It will be negation of P or Q, negation of P or Q and negation of R. And negation of R. So this and this will get cancelled. It will be P or Q and negation of R. So this is based on the example 2, under that example 3 and example 4. I hope it's clear with this 4 problems under the example 2. Now let us go to the example 3. Here they are told that express the following proposition in terms of only NAND and only NOR connectives. That means they told that only NAND, when you solve one's negation, for example this negation piece there, right, you should get only this NAND itself, only NAND. They should not be NOR at all, one term. And only NOR should be there when you get a final expression. So this is what they were told, only NAND and only NOR should be there. So let us solve the first problem over here. First problem. So what is the meaning of first problem? They are told negation P. So this you have to express in terms of only NAND and only NOR. Only NAND and the only NOR. So what it will be, negation P is there. Can we write this logically equivalent to, let the negation be as it is. Can I write P as P or P? Can I write P as P or P? Yes, I can write P as P or P. Which law is that? We know idempotent law, P or P, or else we can write in terms of P and P as P and P. So first term we'll take it as P or P. So you know that now it is negation P. You know in idempotent law, P is logically, or else P or P is logically equivalent to P, and P and P is also logically equivalent to P. So this is law of idempotent law. So I just replace P with P or P. Okay, I replace P with P or P. So you know here not is there, and here or is there. So what is this logical equivalent to? P not, and this or is there, P P. So I solved, expressed the following propositions in terms of only NAND and NOR, it is there. So I expressed in terms of what? NOR. Similarly, they told NAND also. So how can I solve the first section again? Also, I can write here, I'll write here also negation P can also written in terms of this way, right? P and Q, P and P, this way, P and P also we can write. So what is this? Not and it is nothing but logical equivalent to P NAND P. So you can see here, first one I express only in terms of NOR, and other way also I solved and I replaced only in terms of NAND. The formula I just used is idempotent law, that is P I replaced with P or P I replaced with P, and outside not and this or is NOR, and outside not and this and is NAND. So we got both in terms of only NOR and only NAND. Let us now solve the second problem. Let's solve the second problem. The second problem he has told is, he has told again express in terms of only NAND and only NOR. So it is P and Q. So we'll try to apply one concept is double negation for this, okay, because I'll tell what will happen. We'll try to apply double negation for this. So you know, double negation of P and Q is always nothing but this itself. So let us solve this particular double negation. So what we do is one negation will keep out, other negation will apply. One negation you keep out, one negation you put like this and write P and Q. Okay, now apply here we'll apply De Morgan's law. Let this not be out itself. Here we'll apply De Morgan's law. So what it will be? It is nothing but negation of P nor negation of Q. Agree? Negation of P nor negation of Q. Now I want again in terms of only and itself. So you should prove that again. If you see here, this if you try to, you might think this is now not and this is all. I can put a NOR over here. Yes, you can put a NOR over here, but this should be resolved again. They should not be only not or anything. It would only NAND and only NOR. Everything should be, finally you should get in terms of only NAND and only NOR. So what I can do is I'll keep this negation as it is. This negation P or this entire term negation P or negation Q is there, right? I'll do again, I'll apply idempotent law for this. This can be same, like I'll apply this law, that is P and P will give you P, that is here. This entire term you take it as P. So this and this, so this and this will give this ulta. Usually we applied, we took this and we brought this, right? Now by this is there, I brought double terms P and P. So what it will be now? Now I'll try to connect this and this is what NAND. Okay, so I'll just try to solve negation P or negation of Q. This not and this is nothing but NAND, and then again I wrote negation P or negation of Q. Okay, so here this negation P or negation Q can also be written as negation out and P and Q. Okay, and this we got it, and again this I can write it as P and Q. So just check here, what is this? Not and that is nothing but P and Q and P and Q. So you can, now you can compare the answer. I told, right, it should be only in terms of NAND and NOR. So that's why I did here again one more I inserted. So this is P NAND Q, NAND, P NAND Q. So only NAND you can see. There should not be an or negation something. It should be in terms of only NAND and NOR. That's why you might have thought like directly let us put this and we got this particular symbol. For example, you might have thought that if I solve this and this, if I solve, you'll get it as negation P and negation Q. No, this is not in terms of NAND and NOR, right? Your negation P and negation Q is there. No, it should be in terms of this way. NAND and NOR. Either only NAND, only NOR. This is not a formula of NAND, so we cannot solve that way. That's why I took this entire as P, and again this as one more P, and then I resolved further. Okay, this is regarding P and Q. Only NAND you got. Now try to find only NOR. How can you find only NOR? One more way is I'll solve here. Okay? One more way. Similarly, other way we can solve similarly P and Q can be solved. Here you got only NAND, right? Now you should get only NOR. So what if you do, you'll get only NOR is I'll just apply double negation for this. You know, double negation of P is P itself, and Q I'll write it as double negation of Q. So I can put a bracket, no issue, right? I can write here. I can write here double negation of P is nothing but what? P itself, and this is equivalent to double negation of Q. Now this you take it as a P, this you take it as a Q. So negation P and this you take it as Q, this you take it as P. So what is negation P and negation Q? It will be nothing but negation of negation P or negation Q. De Morgan's law. Agree? Negation of negation P or negation Q. Now try to insert this and this. Okay. So what it will be again? It will be nothing but negation P, this not and or. Nor I got negation Q. Negation negation. Now I got one NOR, but this should be again in terms of NOR. NOR means what? Perfect. P NOR Q, it should be there. So what can I do with this to resolve and this to resolve? Simple. We took the first example, right? Same way. What we do is negation of P. I want in terms of NOR, right? So I'll put P or Q. Sorry, P or P. P or P is nothing but what? P itself. P or P is nothing but P itself. So I'll just put negation of P or P. Okay, this as it is, I'll write, and here also I should replace this. Well, Q is nothing but Q or Q. By which law? By idempotent law. Now you know not and or is there. So I can just write P. Sorry, P. I can just write. You know, I applied just P. I wrote P or P. Q. I wrote Q or P. So not and or is there. Not and or is there. So what it will be? P nor P. This will be again nor. This will be Q nor Q. So this is what is the required result I wanted to get. This is what the required result I got. I wanted to get it. Okay. So this is based on the example 2. Example 2. We solved P and Q. Next we'll solve the P or Q. Okay. Third one is based on the P or Q. So what is P or Q? Similarly, how we did P and Q, P or Q also can be solved by same concept, that is double negation of P or Q. So apply one negation, keep out one you apply De Morgan's law. So it will be negation of P and negation of Q. Okay, negation of P and negation of Q. Now now you know this and this will give you what? If you just apply if you apply this and this will give you NAND, but again you have your negation P and negation Q. So similarly, how we did that, this you take it as P, okay, this you take it as P, and you want anything NAND or NOR. We'll try to obtain NOR. So you have, if I resolve this, if I apply De Morgan, you take this P. If I apply De Morgan's law, what it will be actually? It will be nothing but negation of P or Q, right? Negation of P or Q. So negation and NOR will give you this symbol if you apply for this. So this, if you take P and or P, if I do P and again one more P if I take, that also will be like this symbol. So in between also I want this symbol itself, only or. So I'll be doing So I'll be doing this negation, I'll keep as it is. Here I'll write negation of P and negation of Q, or because this will give you NOR, this and this also should give NOR, only NOR, right? Again I'll write P and negation of Q. Okay, so here negation of P and negation of Q, or negation of P and negation of Q. So by De Morgan's law, what it is, what will be this statement actually? Negation of P or Q, or negation of P or Q. Okay, so this is what you'll get by De Morgan's law. So this will be nothing but negation. Negation out you keep as it is, negation, and this will be nothing but P or Q, that is P nor Q, or P nor Q, P nor Q. So this is our notation. After that, this and this is OR again. So write P nor Q and put this inside again, nor P nor Q. So this is what we wanted, the required result. This is one way, we got only NOR. Now I want again only in terms of NAND. Only in terms of NAND. I'll repeat this section. I applied double negation. So you know that double negation is nothing but this itself, equivalent to this. One negation I took and one negation I applied De Morgan's law. Now if you might have thought that if I apply this over here, it will be NAND. Okay, NAND. Now when you solve this also, you should get NAND itself. When you solve this also, you should get NAND itself. So for example, I'll just solve the other way. We'll try to see whether we'll get not P and not Q. So what it will be actually, negation of P, NAND negation of Q you will get. NAND negation of Q will get. Okay, one way you will get it as this way. Other way I told, negation P, NAND negation of Q. So how can I solve this further? You know that this should be resolved. So you should write in terms of P and P, NAND negation of Q and Q. So you know that this and this will give you P and P, and this will give you again Q and. So this is what, only when in terms of only NAND, this is only NOR. One way you can solve this way itself, this one way you got this way, for example this way. One way you can solve this way. This I'll solve again over here, so you'll get confused. No, I will solve again over here. P or Q can also be written as, okay, we'll write the same thing, negation of P or Q. Okay, then we can write this is logical equivalent to negation of P. Second step is same, negation of P and negation of Q. Okay, this not and this will give you what, NAND. So write as it is, negation of P, NAND negation of Q. Now I want to remove not P. So not you keep as it is. Can I write P in terms of, I want NAND, right? P and this not this itself, negation of this I can write it as Q and. So what is this? This not and. So it will be P and P, and this is this one, and it will be nothing but not of this again, Q and Q. So this is what is the required result I wanted to get. This is what the required result I wanted to get. So I got this as P NAND P, NAND again Q, NAND P. So this is how we are going to solve the third problem. So the last one is P conditional Q. So let us solve the P conditional Q section over here. P conditional Q. So you know what is the formula for P conditional Q? What is the formula for P conditional Q? What is the formula for the P conditional Q? It is nothing but negation of P or Q. Negation of P or Q. So what is negation of P or Q? Can I write negation of P in terms of P or P? Okay. Negation of P, I can write it in terms of negation of P or Q. This way I can write it. Okay. So what is this actually notation actually? This is nothing but this and this you try to solve. What you'll get? P nor Q, and this you got it or Q. Now this also should be replaced by NOR itself. So what should be there? I want a negation. So can I put a single negation for this particular expression? No. Instead, See, this I got it as negation and or was this, so I got nor. This also should be replaced in terms of nor only, right? Nor, once you get nor, here everything should be nor itself. So again, if I want a nor, I need a negation somewhere over here. I can't apply single negation, so I apply the double negation. So this I'll apply entire term. If I apply double negation, what will be the meaning? This, if it cancels also, it will be this, right? So what I'll do is I'll keep one negation over here, one negation over here, and I'll solve this particular negation over one negation over there, and then I'll solve this particular negation. So what it will be, I applied negation for this, so it will be nothing but one negation over there, and this will be, this formula will apply. What it will be, negation of, or else no, we'll take this particular step as negation of p, negation of p. We apply double negation over here. Okay, so let that double negation be as it is. We'll just place this term again twice, is p condition q or q or q, and or again or q. I'll tell why I did that. I wrote this p as p because when I apply this particular over here, one will be going over there, one, this will be going over there. So I'll apply that particular term. Okay, or else no, or else we'll wait. I'll just solve 1 second. Or else this will be, this was p. Clear? I hope it's clear. See, first I'll repeat again. Negation, I did, negation was there, I did p or p, so I got this particular law. Here or is there, and if I want to do nor, I need one negation. I cannot apply one negation. Instead of that, I need to apply two negations. So this I kept as it is. Now this negation I'll put it over here so that it will be easy. So we'll put like this, p nor q. Other way also you can solve. Let us solve the easiest way. This was q, right? Q as it is. So what I did, one negation, and this I took as it is, and I wrote, I applied an arrow and I wrote q. Now see over here, now it is in the form of nor itself, but one negation is extra. So what I can do, I need again, I need one negation is over here. I need to remove this negation. If I want to remove this negation, then there should be something like or again, or something like or. So what I'll do, this entire term I'll take it as p. So negation, let it be as it is. This entire term I'll take it as p, p or q, again or q. Then I'll put one or and write this term again in terms of p or q itself. Like p or q or q. That is this way. Why I wrote, I hope you understood. One not is extra over there. So I wrote that particular term. So what I'll do, this not and this or, you know what it is. I'll replace with not. So p q, q, and then again this one, then again p q, then again this particular. So this is how we are going to solve. I'll repeat if you want. P conditional Q formula is negation P or Q. What I did is, for this negation P I wrote it as P or P. This way I wrote. This and this will give you P nor Q, and or Q as it is I wrote. Now, or is this I should replace. So I need one negation, right, to apply this. To apply this particular symbol, I need one negation, and then it should be P or Q, something like this. But I don't have this negation, so I cannot apply one negation. According to the rule, double negation is equal to the entire term is this same. So I apply double negation. I resolved this negation and this negation with this particular thing, but I have one negation. How can I remove this negation? This entire term or something. You can do and also, but we want one. You can see here you have only nor over here. So this entire term or this same term. Okay, I did this entire term or this same term, that is nothing but this I took it as P. So you know that P or P will give you P. So here that P or P is over here. This is P or P, and this not. Now this and this I applied, so I got this particular expression. Okay, this and this I got, so I got this particular expression. So that is regarding P conditional Q, where everywhere you got NOR. Now I want to get NAND. So if I want to get NAND, what can I do? If I want to get NAND, what can I do? I'll solve one more method over here. This is one way. If I want to get NAND, what can I do? Nothing. I just applied. If I want to get NAND, I can just apply double negation. I'll try to apply double negation for this. P or Q. What it will be? Double negation of this. Try to solve one negation, you keep it out. Yeah, so this will be negation of negation P. So it will be just P, right? And this will be and negation of Q. Okay, negation. Just double negation. One negation you keep it out. One negation you apply De Morgan's law. So it will be negation of P, that gives P, and negation of Q. This or is replaced by and this negation will be got to this negation P. Now you know that is we got here we got what? We got NOR. Here we are supposed to get NAND. So what I'll do is this negation is there and this AND is there. So I will just put P NAND negation of Q. P NAND negation of Q. Now P, this is further solved. How will I try to remove this? I want NAND and NAND again. So Q and Q. So it will be nothing but P NAND. Negation of Q and Q is nothing but Q NAND Q. So this is what is the required result. So these all terms I repeat. Students kindly note, this is again replaced and wrote in terms of NAND itself. This is in terms of NOR itself. So this is how we are going. So first double negation for this entire term I solved over here. One way is this way, one way is this way. Okay, so one way I got this, one way I solved in this way, one way I solved in this way. So both NAND and NOR operations I got in this particular things. So this is how in the four things also we had to apply in terms of only NAND and only NOR. This is the concepts based on the NAND and NOR. Thank you.